I'm the author of Open Objects, and I just want to thank you for stopping by and for your interest in my work. On the next few minutes, I'll be your tour guide around the set of demos that I've prepared that will show the concepts behind shape and open objects. I hope I can get you impressed, so let's get started. So, on this first demo, which will be a very simple one, we will use a console application to try to explain what's the difference between an open object and a regular .NET object. So, I've just created a type that I will call it my class, and I will use an interface to expose its methods. So, this is just a simple type that it will have only one method called write-to-console. Okay. Now I will make this type implement its interface, and then I will add the logic to the type for output the message to the console. Okay, this is very basic stuff, and I'm going to wire up here in the program. I'm creating a loop so that the console doesn't close, and if I auto-instantiate this object, I would just do new my object, and I would call the method, right? So I would fire up the console, and here we go. So, and if I want to make changes to this object, what should I do? Well, I will try to do it while the program is running. I will save, and out of luck. So I will try again because I'm very stubborn, and I will save, and out of luck again. I have to stop everything and make my changes and recompile and run again. So this is very, very sad. So shape to the rescue. I will now go to the package manager console, and I will try to install the shape NuGet package that is still in beta version, and let's see how it can help us solve this problem. As Jeff Atwood says, this recompilation tax problem. Let's head over to that original class that we added in the beginning of the demo, and let's do some magic with it. We will add the shape attribute to the class that is found on the shape core namespace, and instead of instantiating the object like we did, we will use a special class called shape object, and that shape object is going to give me an open type for my class. I will now call the method this way, and I will run the console and see if some changes will happen. Okay, so I will put Visual Studio to one side and the console to another, and let's try to change the code and hit save. Okay, see, I'm saving the code, and on the console on the right, it's changing the text. So I'm typing and changing, typing and changing. I don't need to stop and recompile and lose my focus. This way I can be much more productive while I'm coding. It makes C# almost a scripting language because you don't need to recompile every time you need to make a change. Shape will gladly do that for you behind the scenes, and you can stay focused on the thing that matters, the code, solving your problems. So this is the basic concept behind open objects. It's objects that can have their behavior opened at runtime. And with this in mind, we can do a lot of crazy stuff, believe me. This concludes our first demo. I hope you guys have liked it. I surely hope that you understood the difference between the objects that we use every day, these closed objects that during execution time we cannot change them, and this new breed of objects that I call open objects. Next up, we will use open objects in an MVC application, and we will do some really awesome stuff. Stay tuned. Thanks for watching. Hello, welcome to our second demo on open objects. And this time we are going to wire up an MVC application with Shape. I've chosen the ASP.NET template for MVC, and I am installing the Shape Nougat package, and you can see up there the auto refresh feature that we will talk in a moment. And now let us just check that everything is okay with the template, the navigation, everything is fine and dandy. So now we need an entry point where we can hook up our shape to the MVC runtime, and as expected, that entry point is an IOC container. I have pre-installed AutoFac, and now I'm going to do the basic plumbing that we need to do when you need to hook up IOC container with MVC. This has nothing to do with shape, but I'm showing here for the matter. We need to hook up a default controller factory, and then we need to pass our container for this controller factory for our controllers to be resolved. The point of junction between MVC and shape, it's the container. You will see that when we tell the container to resolve an instance that implements the iController type, we'll use a factory method for that matter. And that factory method, it's that object where you saw on the other demo, the shape object, okay? It's on this AutoFac config class that will do the plumbing necessary to hook up shape to the container and inherently by the MVC runtime. Now register our home controller on the container, and as I've mentioned, we will pass the shape object as a factory for resolving home controllers. Whenever the container will resolve a home controller, it will forcefully pass by our shape object method, and the shape object method will return an open object, okay? An open object of home controller, and that's where the magic happens. Before going to the controller, let us just pass for the global ASAX file and add a line for shape to configure itself automatically. This has to do with logging and other settings that you can check out on our wiki. And now we are going to instantiate the controller factory and pass it to the MVC runtime. We go to our controller and we add the shape attribute namespace. We will now execute. We will push Visual Studio to one side and the browser to the other. Just to remind you that we have the shape auto refresh feature, and we have chosen Chrome to auto refresh automatically on save. This is a huge productivity tool, as you will see. I am typing in real time, I'm changing the controller, I press save, and look what happens. The browser is reflecting the changes. I didn't have to stop and recompile the application. I can be much more faster. So I will go to the views and I will make some changes. And I will go to the controller and put another message on the view bag that the view will reflect. As you can see, I have never stopped. IIS is still running and we are working, and we don't need to recompile the application. This is real-time developer productivity. I don't even have to do a refresh on the browser because Shape will handle that for me. I just have to type, press save, and the browser will refresh it. And this, as you saw on the first demo, it's the exactly same behavior that we had on the console. We can have all these behaviors on every .NET project type. This is great. Now let's try to change the about action method. See, I am changing. I changed the message to really, and now I'm going to change it completely to return a string instead of a view. I will press save, and here we go. The first part of this demo is almost done. we will continue to evolve this web application and adding more behaviors and on the subsequent demos. I just want to draw your attention to what I'm doing now is that I'm changing the home controller signature. I'm adding a new action method and I'm adding a new view. I still have the application running. I am not recompiling the application with Visual Studio with Control Shift B, and I will call it on Chrome and everything will work. How about it? We have reached the end of this demo. Thank you for watching. Next up, real-time services. Hello and welcome to the third demo. We are back on our MVC application and now we will try to add a new service dynamically. The application is just where we left it off for the last time. It's still running on IIS and we are on Visual Studio and we added this new class that we call this time service. And just to remind you, the application wasn't compiled with time service and I'm adding this time service on the fly. To do that, I need to transform this time service on an open object by adding the shape attribute. And then I will just make some changes to a view that will reflect the result on the home controller method that is calling the service. Now we will use the same method that we created earlier when we changed the home controller signature. And you will see time serving executing beautifully, and we don't even have to refresh because the auto refresh feature of shape will handle it. And as soon as we press save, the browser will automatically update itself. And that's it. This concludes our third demo. Next up, real-time model binding validation. Hello, welcome to demo number 4, where we will see how to make real-time model validations with shape. We're inside our profile VM from our MVC app, and we've transformed it to be an open object, really. If you look at the shape attribute on top, and now we can do development in real time with this class. And this implies the validation attributes. As you see, on the right I have a form that I am constantly changing and updating. And I am changing the validation attributes, the error message, and you'll see that it will automatically be propagated when a change happens. This concludes our demo about real-time object validations, and let's go immediately to quick production fixes. Hello, we are now on our 5th demo and we are going to simulate that our MVC app that we've been working so far has now been deployed to the production servers. This MVC app was detected that it had a bug on this form. If we inserted any number, it would accept SDH. So we need to do a fix. And traditionally, to do a fix, we had to recompile the app and deploy the app again to IIS, stopping servers, and so on and so forth. But as we made our objects open objects, we just go by using an FTP client, and we can use the embedded one that's on Visual Studio, and we will see that Shape has organized all our sources, and it's very, very simple to go to a source, open it in Visual Studio, edit it, and publish it again to production. So we are going to the form where we were on the demo before this one, and we are going to add this required attribute on the fly. As we saw on development time, when we added a required attribute, it will automatically be propagated on open objects. So that's why we like to say that when we use open objects, we are preparing the application for the future, because if we had to correct a bug, we don't need to stop the services. So as you can see, I already changed the validation, and now the field is saying that the age is invalid and IIS continues to work. Because these files are out of the IIS, the app pool is not recycled, so we can change it at ease. Um, I'm also doing something because let's imagine that there was this requisite where we had to put another extra field on the form. So I'm adding on the fly in production a new form field. Because I have made the model of this class an open object and the controller is also an open object, I can make the changes, save them, and see the immediate results. There it goes. The form is altered. Bug is corrected, and we're all happy. And this concludes our demo. Welcome to the fifth demo. In this demo, I'm going to show you how you can extend an open object that's already deployed. I am connected to our Azure site via the FTP of Visual Studio, and I am going to add on the fly a new open object that will consume an external service. I am calling this object the IP Catcher plugin. I'll add a class to Visual Studio, but I will name it .shape instead. .shape is the convention that Shape uses when we are in production. I will now add the shape attribute to our plugin and the corresponding logic. This plugin will be consumed by another open object, and this is a case of nesting. You can read about nesting on our wiki. So, after the plugin is in place, we just need to add it to the home controller open object. And to do so, we will add a new method on the fly, and we will create a new shape object. It's as easy as this. So we will go to our homecontroller.shape file. We will issue using web application 2 plugins because that's the namespace where the plugin resides. And now I will create this getIPinfo method. And inside of it, I will create a new shape object for my IPCatcher plugin. And now I just have to call its catchIP. When I press save, the auto refresh feature will automatically update, and if I go to Chrome and hit the endpoint, you will see that it will work. This is the easier way I know to create a plugin on the fly, deploy it directly on production, and have everything working smoothly. And this concludes our demo. Next, source code APIs. Welcome to the sixth demo. In this demo, I would like to show you a notion that Shape has called Source Code API. Source Code API is any remote endpoint that you can provide to Shape to obtain the source to be executed inside any open object. So, you just need to feed the sources to Shape, and your open object will be executed with those sources. To prove that, I am going to implement the iSource code interface that Shape has. I'm going to create a GitHub source code API. My GitHub source code API class will download any source that I have on my GitHub repo and create a shape object on the fly. So I have created on my GitHub repo a dummy repository called test, and I have there an open object. As you see, I have this serializer plugin that's, with the help of JSON.NET, will serialize things to JSON. So I am going to create a method on my open object home controller that will call the logic from my GitHub source code API to retrieve that source code, retrieve the dependencies because I have a packages.config there. So I will go to NuGet and extract all the NuGet packages, and then you will see that I can execute and everything will work. So there you go. We've just executed code that was on a remote repo and we imported it to our open object. And this concludes our demo. Next up, we're going to talk about snapshots. On this demo, we will show a very important feature of Shape called snapshots. Snapshots are safety nets for production code whenever we make direct changes on the code. I'm going to demonstrate this feature by using the FTP of Visual Studio, getting the home controller open object, and totally trashing it. I'm going to write rubbish on the constructor. This will make the code impossible to compile, but as you see, when I press save, because of the snapshots, the application won't break. You see, the snapshot version ran and everything stayed the same. For our last demo, let me show you a very cool feature. Let's try to use Shapes Auto Refresh to refresh 3 browser instances at the same time. When you're doing web development, you know that testing in different browsers is a very important thing. So I have all 3 browsers, i.e. Firefox and Chrome, pointing to different actions on the home controller. And you will see that when I hit save, all 3 browsers will have their content updated. And there you go. As you can see, this is a very interesting feature. Well, we've reached the end of our demos. I hope I got you excited with this and that you could see the real potential behind Shape and Open Objects. If you're interested, you can learn more from what I've shown you here by going to our Get Started page guide on shapeframework.net and our documentation page. Thank you very much. Follow us on Twitter, make noise, give us feedback, give us ideas, and we'll try to make this a huge product. Also, go for the beta and try it, and go for our issues page and try to help us to clean all the bugs and make this a huge product. Thank you very much.